Right, so in this video I'm going to be explaining another approach for event extraction which uses distance supervision. Distance supervision from, for example, in relation extraction you have a knowledge base, then because you have entities, it's a triple entity relation entity, then you can automatically annotate your text with those relations. But it was noisy, so it was some methods to overcome this problem. But distance supervision can also be used in event extraction. For example, in this paper in 2014 from Stanford. So distance supervision is a successful paradigm that gathers training data for information extraction systems by automatically aligning vast databases of facts with text. Previous work has demonstrated its usefulness for the extraction of binary relations. As I said, for relation extraction we have seen. But distance supervision, you can distantly supervise name entity mention extraction. This is one approach. You can distantly supervise event arguments extraction. This is another problem. You can distantly supervise event types extraction. That is another type. Here we extend the distance supervision approach to template-based event extraction, focusing on extraction of passenger counts, aircraft types, and other facts concerning airplane crash events. We present the newly public available dataset and event extraction task in the plane crash domain based on Wikipedia info boxes and newswire text. Using this dataset, we conduct a preliminary evaluation of 4 distantly supervised extraction models, which assign name entity mentions in text to entries in the event template. Our results indicate that joint inference over sequence of candidate entity mentions is beneficial. Furthermore, we demonstrate that Serial algorithm outperforms linear chain CRF in a strong baseline with local inference. So we make 3 contributions. First, we present a new research dataset for distantly supervised event extraction centered around airplane crash events. Second, we use this dataset to conduct a preliminary evaluation of a number of extraction. And third, the experiment that we learn them jointly. So our dataset we want to do a slot filling task. We define a slot filling task over 8 slot types. For example, flight number, operator, crash site, passengers. These are the types of a particular. These are slot types. We have 8 of them. So we have different slot value. For example, Wikipedia title could be Flight 967. Or label frequency in noisy training data. For example, survivors is a number, or aircraft type is organization. Then we do a simple local classifier. First, we do a simple local classifier. By using multi-class logistic regression to train a model which classifies each mention independently using the noisy training data. So these are feature sets for mention classification. For example, dependency features are very interesting, very important, significant. The second experiment is that we compare our simple local model that I just explained to a sequence model with local inference. And we use maximum entropy Markov model. Of course, this article is quite old, it's in 2014, so that's why they are using these methods. And finally, joint models. So they use linear chain CRF model. I have a playlist for CRF. So for our second joint model, we use certain algorithm to infuse global decisions into a sequence tagger. So it's a general framework for training classifier which make globally optimized choices in a structured prediction task. The algorithm operates by associating training mentions with cost vectors corresponding to the global sequence-wide impact of different label choices. We want to train an optimal classifier based on a set of global costs, but we would like these global costs to be computed from the decisions made by an optimal classifier. So we initialize a set of cost-sensitive examples. Then for each mention, we go and in a sentence, we go and classify mention left of M using edge. Then for each possible label, we let M have label L. We classify mention right of M, and then we update the cost. And finally, we learn the classifier. So these are the performance of SMLI and local models. So we describe a newly public available dataset and extraction task based on plane crash events from Wikipedia info boxes and newswire text. But in the third experiment, we demonstrated the effectiveness of a noisy OR model for label aggregation. We showed that syntactic information, those that are dependency parsers, and local context are both important for model success.